Awesome. So we're live now. I'll kick off. Thanks, Mary, for getting all set up.
Yeah, of course.
So I'm
I'll let
gonna
you take it away.
share my screen. Can you make me host, please? Thank you. Okay. So I'm pretty excited for today's. I think it will be a fun one. It's a new webinar I put together, which is the open source comparison. We're going to talk about all the open source feature stores. Really, we're mostly just going to talk about Featureform and Feast. Um, this is on the heels of Tecton officially kind of seeding their maintenance of Feast. So right now, Feast there's not really a lead main contributor. And so, yeah, we'll talk about, we've had a lot of people come and ask us how we compare to Feast. We've had a lot of people come and ask us, I guess, what happened, what we think happened, why things are different with us, etc. So I just thought it would be good to kind of give our view on Featureform and Feast. We'll talk, I want to make this mostly technical. Um, we will talk about the feature store landscape. I will talk a bit about the project histories and the structural differences between the companies or the products, rather, projects, and why we're kind of set up for long term and why Feast is kind of in a more precarious situation just because they don't have anyone maintaining it. And that's pretty much all we'll talk about, but it's non-technical. The rest of the majority of the content will be about the architecture differences between Feast and Featureform. We'll go through code. I will show you code of both of the projects. I will show you UI comparisons of both of them. And I'll end with a value prop breakdown, which is so the beginning will be very, very like deep technical. It does this, it doesn't do this, it does this, it doesn't do this, this is fast, this is slow. And the value prop will be to zoom out at the end after we go really deep. Like let's zoom out now that we have all the details. Why does this matter? And why are the differences matter? So let's begin by talking about the landscape. So there's three um, feature stores that still really exist in open source. There's Feast, Featureform, and Hopsworks. Um, the reason I haven't really talked much and won't really talk much about Hopsworks in this specific webinar is their license is AGPL, which typically for any large-ish company, it's just kind of a no-go. It's just a really hard license to use unless your whole product is open source. And we're Mozilla, pieces Apache, which are much, much more open um, licenses. In terms of this like stars, which I'm just using as a generic, I guess, indicator of popularity, all the projects are popular enough. Like we're all in the same magnitude. Feast is the most popular feature store. Um, Release cycles, uh, we release monthly, sometimes more than monthly. Hopsworks, I just looked at their releases in the open source. Again, like they don't have like a place where they put what their cycle is, so I just kind of eyeballed it to 2 to 3 months. Feast, on the other hand, hasn't actually released anything since September, and even then, it's very sporadic. Like there was like 6 month periods where nothing got pushed. Um, Feast no longer has a maintainer as of a few weeks ago, officially. Tecton has ceded maintenance of Feast. Um, our company and open source project share the same name, Featureform, so we maintain the project. Hopsworks is maintained by a company called Logical Clocks. Um, Business model, and I'll talk more about this. Feast doesn't really have one. There is no like there's no Feast as a service company. There is no managed Feast company. There is no like consultancy around Feast. There is no business around Feast. There like loosely was of Tecton, but even then, there were two completely different projects and products. Featureform is open core, so our approach to our business model is that we give everything in open source except governance and stream processing. Hops works similar. It's hosted and services and a few other functionality. So we both kind of have businesses around our products. The architecture, we'll go much deeper into this. If you've been to any of our webinars before or read any of our content, we talk a lot about the three types of feature stores. There's a literal feature store, which both Feast and Hopswork fall into. There's the physical feature stores, or sometimes called the feature platform, which is what Tecton would fall into. And then finally, there's the virtual feature store, which is kind of an architecture that we define. And Gartner calls it the logical feature store. So if you go to the Gartner hype cycle that went out, the last one, they don't have feature store as a standalone category. They just have logical feature store. So they've kind of defined that our approach is the approach that they're interested in. If at any point in time you have questions, feel free to just throw them in. If you're on the Zoom, you can just throw them in the Q&A. If you're on LinkedIn or Twitter, you can just put them there. So next, let's talk about the structural differences between the Feast project and the Featureform project, just to really kind of understand how they're different and why they're different. I want to start first with the histories. So I'll start with Feast. Again, like I didn't work on Feast, but I've been very close to the project, to users of the project, to maintainers of the project for a long time. So loosely what happened, Feast was built at Gojek. Gojek is like a competitor to Uber. It was built kind of in tandem with Google, but it was specific. Gojek was a huge buyer of Google Cloud and probably continues to be. And so they kind of worked together to design Feast. Feast was eventually handed off into open source. And it kind of sort of became maintained by another feature store company called Tecton. I won't go into all the details of why that happened and all that. But generally, you can just think of it as it was part of a company. It got open sourced. It was kind of spun out. Gojek has made PRs on Featureform's repo, so it's not like I wouldn't necessarily call Feast a Gojek project anymore. I think it's kind of lost that association. And then Tecton kind of took over the maintenance of it. So they hired a lot of people who were the main maintainers of Feast. As of officially, as of about a month ago, Tecton released a press release where they said that they are ceding their maintenance of Feast. So currently, Feast is kind of doesn't have a home. It's unmaintained, and that's kind of the state we're in now. It's kind of unclear what will happen in the future, and I don't really evaluate, but I have some sense of where it's going and what's happening. I don't want to really opine, but currently it's in a state where there isn't really anyone maintaining it, or no company maintaining it. Featureform, we open source Featureform. I built Featureform with a different team at my last company, and we built it. We were doing recommender systems for about 100 million monthly active users. We were predicting subscription. We were predicting churn. We were just working with a lot of data. And most of what we ended up doing was feature engineering. This is kind of pre-MLOps being really a term, and definitely pre-feature store being a term. So we built a lot of stuff in-house for ourselves. And one thing in particular that we built was, we called our data platform, but nowadays it would be called a feature store. And that was kind of the basis of Featureform. So I decided to open source it. And about 3 years ago, I went full-time, built a company around the project. We've raised over $8 million to date to continue building Featureform, open source, and commercializing it. And so that's kind of where we are today. So why does it matter that there's no company behind Feast? The short answer is pretty much every open source project that is successful has a company behind it, typically has a company that commercializes it. or at the very least has something like Google or a giant behemoth that kind of maintains it and uses it deeply internally. Without that, you kind of need, until projects get big enough, like Kubernetes big, um, it just helps to have someone being the captain, navigating, leading the way, and having a constant amount of contributors and people building and fixing bugs. With us, like the company, commercialized company, open source have the same name. Feast, like we talked about, doesn't really have one. Spark has Databricks. Redis has Redis Labs. Kafka has Confluent. Like you name it, pretty much any popular open source project has a commercialized entity backing it. And oftentimes that happens really, really early before the projects are that big and they become kind of the steward of it. It's kind of what makes open source work in most cases. Okay, so enough about let's call it business, non-technical differences. Let's get into the tech. Um, we I really want to dive into what makes Feast and Featureform different, ignoring the fact that it's unmaintained, like just product to product, how do they compare? Where are they different? And where is each of our strengths and weaknesses? So I pulled this from Feast's website. Um, this is how Feast describes itself. You have sources. They could be streams, they could be batch. You transform them. So you transform the data to build your features. And then once you've built the features, you register and store them in Feast. So Feast acts as the storage layer and the serving layer. And what makes it valuable beyond just being like a cache for features is it allows you to serve for online, which is typically like low latency interactive models, and offline, which is training. And one thing in particular that's very true, especially of time series data, where is that with time series data, your features change value over time. So the features value in a training set will be different from the features value at inference because like for example, if the feature is a user's favorite genre, your Spotify and the feature is a user's favorite genre, that's changing often, not often, but it's changing. So if you have a training set and you have a feature which is favorite genre or favorite genre in the last week, that's changing a lot. And as that's changing, you want your training set to show the features as they appeared at that point in time. In the online setting, you just want the most recent value of the features. So that's what Feast does. Well, is you store all of the features values, even as they've like at different points in time. And Feast will allow you to serve the newest version of the features with low latency and also serve the historical values of the features to be able to train. We call this architecture. These are things Feast doesn't do. Again, this is literally from our doc, so I'm really trying to make sure that everything I say and do here, it's kind of like treat as you want to be treated. So I'm really trying to use their content about how they talk about themselves to make this a fair comparison. So these are things that Feast itself says it does not solve. One is reproducible training, backtesting, experiment management. Really what it is like versioning. Like it doesn't have any idea of versioning. It doesn't manage training sets. It doesn't manage splits. It doesn't manage labels. It doesn't do any of the feature engineering. What that means is that the feature is a table. It's an artifact. It's the output of your transformation. You store the features after you've built them. Why mention that? It's because feature stores like us and Tecton, we define features as the logic, the definition. Like we don't define the feature as a table. It's like, oh, here's the file that has the features in it. It's here's the transformations that you run to build that feature. And there's native streaming. It doesn't have it. Feature sharing isn't like collaboration isn't a big thing it does. It doesn't have lineage, given what I just described. Like you don't have the transformation, so how can you have the lineage? And finally, it doesn't really have much around data quality monitoring and drift detection. I'll come back to a lot of these things, but this is what we would call the literal feature store. The literal feature store, this is actually the same exact architecture that Feast has, with Vertex, with Databricks' feature store, with AWS's feature store, or SageMaker's feature store. This is the approach they've taken. And they've kind of taken that approach because a lot of cloud companies, when they want to release a product, they kind of copy the biggest open source player, and they just copy the exact same architecture. Is common. And so I think in this situation, they kind of mimicked Feast, and they took that. So this is what we call the literal feature store. And the reason I call it a literal feature store is if you just hear feature store, you think, oh, it must be a database where features are stored. But we don't really think of it that way. We have this concept of the virtual feature store. And the way we work, and I know I see that there's actually a question about how we compare, or like Tecton versus Feast and the Tecton Featureform differentiation. I'll actually talk about that momentarily after this. So the way Featureform works is we try to think of features not as like the output table, but we think of it as the feature lifecycle. In the feature lifecycle, data scientists are constantly experimenting, trying new features, building new training sets, having a repository where everything is stored so that there's collaboration. Things can be shared. You can see lineage. How was this feature? Not just here, I have a feature, but how is it built? I have versioning. I have reuse. I have, once I deploy things to production, automatically having things like data drift detection, alerting, access control, and finally, running the transformations themselves. So what makes Featureform virtual is that we use your compute engine. So you plug in Spark, you plug in your storage engine, it could be like Redis. You plug in all of the stuff that you use, and we will orchestrate it to work together like a feature platform. So that's what makes us virtual. The approach that Tecton has taken, Tecton doesn't use Spark. It has its own internal transformation engine. They call it Rift, I believe. And they have their own storage engines, and they kind of do. If you think of the feature platform, instead of just doing literal feature store, like we're just doing the storage, it does the transformations too. But it does the transformations on its own engine. It does it typically in its own DSL. So they have their own language. You have to rewrite everything and use their language, which is proprietary. And actually every physical feature stores that exists has a proprietary language. Where Featureform, I'll show you soon how it looks. Like you're still writing PySpark. You're still doing your same logic. What we're doing is orchestrating that. So we're managing, versioning, doing lineage, doing monitoring, doing governance, doing scheduling, all the things you'd expect to work, materializing. But we do all that on your infrastructure. So you can think of it as Feast is a type of storage for features. Tecton is a platform where you build and define and store and run all your feature pipelines. Featureform is also it's more of an orchestrator. So you're still defining your feature pipelines in Featureform, but we're orchestrating it to run on your compute. And that's what makes Featureform unique. We've had other webinars and we have other content around how we compare to those types of feature stores. If you have more questions about, if anyone has questions about, feel free to ask, but most of what I'm going to be focusing on specifically is Feast versus Featureform. A lot of the things that Feast doesn't do that we talk about how we do, Tecton does as well. The core differentiation is Tecton does it by forcing you to re-platform all your data onto their stuff, run your compute there, etc. Well, we keep the data where it is. We don't force you to re-platform anything, and we act as an orchestrator. The key values of a feature store are these 5 things: to facilitate deployment, enhance collaboration, organize experimentation. So facilitate deployment, like when you build a feature in your notebook, you're just experimenting. How do I get that to production? Enhancing collaboration, which is, you have lots of data scientists. How can they share and reuse things? Organizing experimentation, which is a single data scientist. We'll talk about this more, but you have all these untitled notebooks. You have tables called like table V2. Increasing reliability. These are things like making sure you handle failures in Spark, making sure that you catch drift early, and finally preserving compliance. So this is what we view as the core values of a feature store. Now that's very different from, again, what Feast views. Like Feast, again, doesn't do lineage. It says that they don't really do things around collaboration and feature sharing. They don't have anything around experimentation because they're production focused. So they're really focused on just the first bit here, which is facilitate deployment. And specifically, it's like this is a production database where you put your features. That's how they would define a feature store, where we would define a feature store as a framework to define, manage, and serve features and deploy features throughout the whole life cycle, from experimentation to production and back, because it's an iterative process. Okay, let's show some code. So I have an example of Feast and Featureform. I put them in the same notebook. We'll see how that works. I'm gonna make this bigger so that you guys can see it better. Okay, so maybe that's too much. Maybe that. So I'm gonna start with Feast. So I have a file. That file is called transactions. You can actually see it here. So what you do in Feast is you define your source. Your source is typically going to be something like a file. And that source has to be, I think they support Parquet, JSON. They don't support CSV, which is kind of strange, but they do support Parquet. And so we just have a Parquet file. We specify the timestamp field as timestamp. We create a feature view off of that source. So you see I'm specifying the source as that transaction source. And I create a view. In that view, I specify the name of this view. I specify the schema, which in this case are two fields that exist in that Parquet: customer account balance and transaction amount. I specify that I'm going to use it in online serving, like in Redis eventually. And I specify the entity. The entity is kind of like a join key. It's like how, like this is a feature that is associated with user. I create a feature service off of that, which I just specify the features and give it a name. And that's all. When I run, then I would run Feast apply. When I run Feast apply, it would register all this stuff for me. Then, if I want to build a training set, what I would do is, because Feast doesn't handle labels, I would go get my label file. Now, kind of annoyingly, my label file is the exact same file I was using earlier. So I have to open that file in Pandas to create my entity data frame. And then I pretty much specify the features and Feast that I want to join in my entity data frame. And then I get this training data frame. And that's just a data frame that I can use to train. It only is a Pandas data frame. It wouldn't support like a Spark data frame or something like that. Great. So that's how I do training. Now, the other thing you're going to want to do is serving for production. So when you serve in production, like when you're training, you can work off of like your Parquet file. But when you're training or when you're serving for production, you're going to want to cache the most recent values of each feature in something like Redis. And so I have, there's like a YAML script that I specified Redis in. And then I call Feast materialize incremental. What Feast materialize incremental will do in this situation is download the file. It was in S3, it would download the file. And then it would loop through and it would kind of write each one of those things one by one into Redis. And then it would be materialized. Then I can use those features. So I can specify these two features and which customer ID I want it for, and it will return a feature vector that I can use. There's a UI, so you can kind of visualize some of this. I can move this zoom thing out of the way. This is how it looks like. I don't need this at 200. You can see that I have my data sources and I have my like feature view and I have these features in it. Now here's the problem. For something like transaction amount, typically you're not just going to use features that are just like raw columns. Typically you're going to build them, right? You're going to use something like Spark to transform your data into usable signals that eventually become features. Those final features are going to be super post-processed. Like it could be scaled, it could be normalized in some other way. It's really post-processed. But I don't get, this is all I get. Like when I look at a feature, talking about like collaboration, I don't have anything here that's usable. I don't know what this thing is. I just know that there's a column essentially called transaction amount. I don't know how it was built. I don't know when it was last updated. I don't know what Spark job runs it, or anything. All I know is that there's a column that I have called transaction amount. This is kind of this is true of Databricks feature store. This is true of SageMaker. This is just a problem with literal feature stores. And the problem is that they don't have, they treat features as an artifact, as an output. It's just a column, a file, or a table. Where in Featureform's case, and we'll get into our code, if we look at let's say a source like, let's do like gene effect PCA. Like not only do I see who built it, where it was run on Spark, I can see the code itself that built it. I can preview it. I can see what the data is. I can get like different like charts on that. I can look at different variants that exist, which are like versions. I can go down the chain of lineage and understand like how was what was the thing before it. I can even keep going. Like this was the raw data set was this thing in S3. And I can even preview that if I wanted to. So that's, I would say, is one of the key differences of Feast and Featureform. And is that we define features as the definition. And we store that definition, we make it searchable, we add that lineage, and we also orchestrate it. Like we're the one that runs those transformations for you on Spark. You defined it in PySpark, but we run it for you. This is different from Tecton, where Tecton, you would define those transformations as well, but you would define them in their language, and then you would run it with on their transformation engine. That's kind of the differences between the three approaches. So coming back here, let's talk about Featureform. So Featureform collaboration is built right in. Every single register call has a corresponding get call, so that I can build off of not just the final features. I can build off of the sources. Like I can build off of the lineage. So I can go and grab this transactions source. I can grab whichever version, we call them variants, that you want. I can get whatever infrastructure that's defined or rather, yeah, like defined in Featureform. So this isn't our Spark. We're not running Spark. But what you would do is you would register Spark like a provider. If you've ever used Terraform, I came up with the name Featureform because what I wanted was Terraform for features, a declarative language to define, manage, and deploy my feature pipelines. So let's go through this code a bit. So I should zoom in again. Yeah. So here I grabbed these three sources. I'm going to show two different data sets. One data set I use to predict type of cancer based on some gene effects of a gene. Anyway, and I'm no biostatistician, so I may get that a little bit wrong. And transactions, which is just it's data set of transactions of things that people bought. We'll start with the transactions one. The goal of the transaction one in the end is to actually build a fraud detection model. So I take my transactions data set, which I got earlier. I create this new variant called default 100. It's the transaction amount divided by, like I have this comment in. And this code right here, this is just PySpark with or without Featureform. What Featureform has you do is decorate it with this function. We're giving all the metadata, the inputs, the variant, which is optional, and the PyDoc we grab as the description. We grab the name of the function as the name of the data set, and then everything in Featureform can be transformed to and from a data frame. So I can get this and use it as a data frame. And so that's what I do here. So it runs, you can see it kind of running, and then I get the data set. So you can see kind of like a little bit about this data set. The other cool thing I can do is I can remove this variant. And let's say I want to change this thing where, so here I have it, if I'm going to get infinity or null, I set as 100. Let's say for whatever reason, I want to set as 0 instead. I can run this now. And, oh, I have to re-off. 1 second. And now you can see it running. And it will actually, like I'm running this on Spark for you. And then you can see it pending. You can view it later. By default, if you don't specify a version, we will kind of build one based off the timestamp. This is immutable. So what that means is like, if I was to run this again, it would just get the same one because it's immutable. It couldn't have changed. If I change it, it'll create a new variant. So it'll kind of regenerate something based off the timestamp. So I'll let that run. I already have one. So I'll keep going. You can see like here, I'm defining more and more transformations. These transformations, eventually, I can specify my features off of them. I not only specify my features, I specify my label, which is also unique in Featureform. And if I have a label and a feature instead of features, I can build a training set. Notice that we specify the inference store as Redis. Unlike Feast, where you have to manually materialize in some like single-threaded CLI process, Featureform runs in Kubernetes. And Featureform will run the Kubernetes job in a distributed fashion, update it. In fact, we have support for things like triggers, so that you can automatically update based on some logic like time, or if there's new files in the directory or whatever. Yeah, and then you can specify the features, the label, to build a training set. And that's it. Now I can see all these things, right? I can look at a training set. I can look at a training set like fraud, simple. I can see what's in here. I can see the features in it. I can see the label. I can look at a feature like average transaction. I can look at what it is. I can see some forms of distributions around it. I can continue to go down that path. If there are multiple variants, like there are here, I can look at all the variants. And most importantly, I mean, the whole point of building features and training sets is to use them. So it's simple to use. You just do client.training set. You specify the name, the version, the model. The model is optional. It's just a string, and we use it for lineage. So we can track lineage from the model all the way down to the original data set. You get it as a data frame, and once it's a data frame, it's just a data frame. We support Spark data frames too. If you give us a Spark context or a Spark session, we'll create a Spark data frame instead, which is also kind of unique to us. We did a webinar last week or a week before about Featureform working in Spark. Here it's just pandas, and I just train a very simple classifier based on it. You can see the data set that gets built. You can see the super high accuracy just because it's a contrived data set. The other thing we support, because we support, again, transformations all the way through, is on-demand features, which is the features that get built at request time. Like let's say there's a request that comes in, a new transaction, and you need to define the percent of how much, like take that transaction divided by the balance. You can define that as like a Python function, more or less, that runs at request time. And with Featureform, you can serve those features. I actually lost it's right here. Here I'm serving those features. So when I serve the features for production, these come out of Redis. I specify the features. Usually I would give these actual variants and not use the auto one, but here I'm just using the auto one. And you specify any parameters, any entities, the model that you're serving to, which is again just a string. And you can see it kind of working. What I love, like when I'm using Featureform, is the ability to look and kind of come through a model, go through features, go through training sets, really dive in deep and understand what is this thing, how was it built, what's the logic that built it. We have the same thing of another data set, which is much more, we do a PCA to create multiple columns. We specify all those features. And then what I want to show off of this one that we also support is batch serving. So you can specify a set of features and you can just loop through them and you can just batch serve to do like a scoring type of model. So that's kind of the difference in feeling of how to use Featureform and Feast. I do also want to talk about some of the maybe deeper differentiations, which are a little more, if you've used Feast in production, these are things that you'll likely have run into. First is deployment. So Feast is a local CLI, and it uses kind of a local metadata store by default. You can make it use Postgres or something to store the metadata. But in general, Feast is the process runs like it's a CLI tool. That means that things like, because Featureform runs in Kubernetes, the con is that it's a little hard to deploy. You have to deploy in Kubernetes. But the benefit is when we do things like materializations, rather than having like a manual single-threaded job, we actually kick off a distributed Kubernetes job and work with that. So we essentially use Kubernetes to do all the glue stuff that Spark and Redis and all these things don't do. We kind of fit in using Kubernetes to fill in all the blanks. Feast does that too, but the way it does it, it doesn't have anywhere it runs. So it does everything via CLI. Serving wise, we are going to release some benchmarks soon, but we're 12 times faster on average than Feast. Feast is aware it's slow. They even mentioned in their docs that it's not really meant for super, super low latency use cases. But you used to have a Java-based serving layer that they deprecated, which was oriented towards faster serving. But now they don't have that. So it's the Python one's the only one that's like generally available and it's slow. Governance, monitoring, stream processing, versioning, lineage, like these are all things that Featureform does. And so that's kind of the key differentiations between Feast and Featureform. I want to talk about the value props of Featureform and our view of it and how we solve them and places where Feast solves them, places where we think Feast lacks. So these are the 5 again: facilitating deployments, enhancing collaboration, etc. With facilitating deployment, most of the time when you're building features, you're building them as transformation pipelines. Like they're not just like files. They're like derived from some set of transformations that you're running, typically in something like running using notebooks. And the problem is, how do I deploy these things? So Feast's approach would be you build a feature, you export it as like a file or something, and then you push that file to Feast. Featureform's approach is you would define the transformations, you'd register the transformations in Featureform, and we'll run them in production for you. So there's kind of this like fence between getting things in production. The issue is what happens when it's not just a simple Spark job, when it's like, hey, I have a schedule. So then that file is changing. Feast doesn't have scheduling. So you'd have to build a whole kind of glue thing so that every time the new features are created, you create a new file, you create a new table in Feast, you kind of work that way. Same with streaming. Like the streams, you would have to push each new feature value to Feast. Or with Featureform, you define the whole pipeline in Featureform and we'll kind of schedule and maintain it for you. And it's really important because most of the time with features, you have batch features, you have streaming features, you have on-demand features, and we support all three. However, otherwise, what ends up happening is data scientists themselves are writing Airflow and PySpark jobs, maintaining those, managing those. Or the other thing that we see much more often is data scientists handing off their messy notebooks to a data eng team, who then has to kind of convert that in production grade code. It kind of would feel like if you're a software engineer writing your code in Python and handing it to someone else to write it in Java to put in production. It just kind of, there's a lot of things that can go wrong in that translation process, plus it's wasteful. With regards to enhancing collaboration, and I guess this doesn't solve by fees. Like this is still a problem with fees because it doesn't do the transformations. Enhancing collaboration, organizing experimentation. Like with Featureform, the documentation is the code. It's when you're writing your transformations, those things are the feature. It's not like you output a file, then you have to kind of document that file. What did I do? How did I build it? Like it's the only way to build that feature is by defining the transformations with them. So they're deeply tied. And so you avoid situations like this where your features are in production, but you have these untitled notebooks that you ran to build them. You have your DF finals, your feature table v7, your Spark submits and YAML files. Like this is what we aim to solve by kind of being a framework for the feature pipeline from end to end. Finally, there's increasing reliability. Once the feature's in production, it's not over. I think that's maybe the main way of how I think of the difference between how we think of this problem and how literal feature stores like Feast think of it, which is a Feast, they think of the problem is kind of treated as, hey, how do I get my feature into production? You just copy it over into the production database. But in practice, you're constantly iterating on features. And the way you iterate is one, just based off of your own analysis, and two, based off of what's happening in production. Features change, things stop working. So you need to have monitoring on one side, and you need to have lightweight experimentation on the other side to have that whole life cycle work together well. And that's what Featureform provides. And I think with Feast's approach, it's lighter weight, but it's kind of really focused on this one piece of the puzzle, which we don't view as the hardest part or the main part. And finally, there's preserving compliance. I won't really get too deep into this, but even in the example I gave, like it's all backed by Okta. I actually saw that my transformation got cut off because I lost authentication. That's to re-authenticate. So Featureform tries to play nicely with secrets tools, of data catalogs, of governance tools. Like our goal is to be the framework that data scientists use. So they're writing their logic and whatever, and it's defined in the Featureform framework, and then we will orchestrate it on whatever. In this situation, it's AWS, Spark, Redis, but it could be anything, even on-prem. Awesome. That's kind of all I have. I know there's a lot of information. I wanted to make sure I got through it all. But if there is time, or if anyone has any questions on LinkedIn, on Twitter, on Zoom, feel free to throw them out. We'll kind of keep this. I mean, we can go all the way to the hour mark, but I can wait a few minutes to see if there's any questions from anyone. Emery, you have eyes on Twitter and LinkedIn?
I do.
Cool. All this will be recorded. We will be sending an email afterwards, which will have feedback form. We'll have a place you can sign up so you can kind of keep up with all of our stuff. Kind of a mix of things. But yeah, and you can always it'll also have a link to our Slack community, which is a great way to get in touch with us. And you can always reach out and ping us in the community or our emails. Most of our emails are just our first names at Featureform. So you could always just email us directly too.
Thank you guys.
Thank you. All right, I'll end the